Okay, so a company is willing to renew its advertising contract with a local radio station only if the station proved that more than 20% of the residents of the city have heard the ad and recognized the company's product. The radio station conducts a random phone survey of 400 people. The first question is, what are the hypotheses? Okay, well, this is pretty simple. Okay. I'm going to do the parameter here. P is the proportion of residents. Let me zoom this out. That recognize company name and product. Okay. So the hypothesis H of O is that P is 0.2 and H sub A is that P is greater than 0.2. Okay? So either this is 0.2 or there's evidence that it's greater than 0.2. Okay? And then the next question is, the station wants to conduct the test using 10%, but the company wants the significance level lower. Now the company hired the radio station. Okay? So the radio station wants to show proof that P is greater than 0.2. Okay, so let's do this. Okay, let's say that we hypothesize, and this is what we are hypothesizing, that P is 0.2 when P is actually 0.25. Okay, so the radio station wants an alpha level of 0.10. Okay. But the company wants an alpha level of 0.05. The company. Okay. So the company did the job. Okay. The company, in the proportion of people that recognize the company's name and product actually went up to 0.25. Okay, from 0.2. So if the company gets its way, then the probability that we will determine this is that shaded region. But if the radio station gets its way, then the region increases to this. Okay, so the radio station would much rather have a higher alpha, and the company would rather have a lower alpha, because even though the radio station did the job, okay, if they don't get a sample in this region here and they don't reject the null that P is 0.2 and accept the alternative that P is greater than 0.2, then they don't pay the radio station. So the company would rather have a lower alpha than a higher alpha. Okay. And then see what is meant by the power to test. Remember, when power to test, the alternative is true. Okay, so what is power? It's the probability of correctly determining that the radio station increased, I'm just going to say, the brand recognition of the company. If you want to put it in technical terms, you can say that P is greater than 0.2. But there's evidence that the radio station increased brand recognition of the company. Okay. There's evidence that this right here happened. That's what power is. Okay. And then the next question is, for which level of significance will the power of this test be higher? Well, where it's the larger shaded region, 1.1 or 0.05. Well, 0.1 is higher alpha, more power. Okay, because we hypothesize it's here, we're going to reject anything to the right, and the actual distribution is here. So we have there's more shaded area in this alpha level, this one right here, than in this one. Okay, because you have that much more. So higher alpha, more power. Okay. And then they finally agree to use alpha as 0.05, but the company proposes that the station calls 600 people instead of the 400 initially proposed. Will this make the risk of type 2 error higher or lower? Okay. All right, well, let me draw this. Okay. Okay, so we're going to use a 0.05 level. Boom, right there. Okay, so alpha is 0.05. This hypothesized. This is the actual. This is a shaded region over here is what? Power. This region over here is beta. Okay. So, what happens if we increase sample size? Well, intuitively what happens is you have more evidence to correctly make the right decision. So what is a type 2 error? Well, a type 2 error is when we find that the alternative hypothesis the alternative hypothesis is true, but we fail to reject the null. Okay, so the company did its job, the radio station did its job, but we determined that it did not. Okay. Well, if we increase sample size from 400 to 600, we know that sample size does what? Well, an increase in sample size increases power. Well, power increases, the probability of correctly making the right decision increases, then beta, or type 2 error, would decrease because you have more evidence. Okay, so if you have more evidence against a guilty defendant, then you're more likely to convict the defendant. Okay, but what happens when you increase sample size? Well, what happens is your variation decreases. So this sample here, this is now my hypothesized distribution, and this is now my actual distribution, and I'm going to still do alpha as 0.05, and if this is, okay, so my p's actually line up, sort of, okay, and my hypothesized p's line up. But what happened? This region originally with a 400 increased to this region here. So this is like what, 60-70%? Well, this is like 95%. Okay, so power went from 60-70% to 95%. So beta went from like 30%, type 2 error went from like 30% to like 5%. So with a larger sample size now, guess what? Your type 2 error will decrease.